Now that we know the basics of how to work with absolute values in equations, let's work through a few examples. So let's solve this equation for y. 4 times the absolute value of y plus 5 equals 19. So I see this absolute value, but there's all kinds of stuff happening outside the absolute value, right? So let's deal with the stuff outside the absolute value first, right? This is kind of a common thing in solving equations, where if there's a piece of an equation that you know how to handle, let's isolate that piece first. So this absolute value of y, we're going to isolate that piece first. So how can we isolate this absolute value of y part? Well, let's get the plus 5 to the other side first, right? That's the last, that plus is the last operation in the order of operations, so it's the first operation we should deal with. So let's subtract 5 from both sides. We get 4 times the absolute value of y equals 19 minus 5 is 14. Okay, and now we can deal with the 4 on the left-hand side. Let's divide both sides by 4. On the left-hand side, the 4's cancel, and we get the absolute value of y. On the right-hand side, we get 14 over 4. We can simplify that a little bit. That's 7 over 2, I think, so 7 halves. Okay, now we've solved for the absolute value of y. Right? Absolute value of y equals 7 over 2. But we haven't finished solving for y yet, right? We need to deal with the absolute value, but now we can use what we figured out earlier, how to deal with absolute values in an equation. When the absolute value of y is 7 over 2, that means y itself is either positive 7 over 2 or negative 7 over 2. Or another way to write that, remember, would be to write y equals plus or minus 7 over 2. And if you wanted to, you could write this as a mixed number. Improper fractions are fine, but if you wanted to, you could write this as plus or minus 3.5. All right. So for this one, first we solved for the absolute value piece, and then we unwrapped the absolute value by sticking this plus or minus on the right-hand side of the equation. All right. Let's look at another example. Let's solve this equation for x. Absolute value of 3x minus 4 equals 2. The thing to notice about this equation that's new is that there's, stuff happening inside of the absolute value instead of outside the absolute value, right? So on our last example, we decided the first thing we should do is solve the equation for the absolute value. And this equation is already solved for the absolute value, right? The absolute value piece is the only piece on the left-hand side. One thing that is tempting to try is to break up the absolute value. So you might think, well, on the left-hand side, let's write absolute value of 3x minus absolute value of 4, and then on the right-hand side 2. But that's a guess. Do you know for a fact that it's okay? Do you know for a fact that rewriting this absolute value in this way as absolute value of 3x minus absolute value of 4, do you know for a fact that that has the same solutions as the original equation? I bet you don't know for a fact. And in fact, I know that this has different solutions. So this new equation we wrote down actually has different solutions than the original equation, so we can't do that, right? When we transform equations, we don't want to change the solutions. We just want to discover the solutions. We don't want to change them, right? So we have to be careful with absolute value, because since it's an operation that we're less familiar with, we can't treat it like it's the same as other operations. It has its own rules, right? And this breaking up an absolute value is not a thing that absolute value does. So what can we do instead? Well, this equation, absolute value of 3x minus 4 equals 2, the absolute value is already isolated on the left-hand side. And we know how to handle an equation that has an absolute value on one side, right? That's when you throw on the plus or minus. So let's do that right away. So on the left-hand side, remove the absolute values. So we get 3x minus 4. And on the right-hand side, because we had a plus 2, we're going to put plus or minus 2. This is just acknowledging the fact that if the absolute value of 3x minus 4 is equal to 2, there are two ways that could happen. The first way is if 3x minus 4 is equal to 2, and the second way is if 3x minus 4 is equal to minus 2, right? So remember, this equation is really an abbreviation for two different equations. 3x minus 4 equals 2. And then the other equation is 3x minus 4 equals minus 2. Right? So this plus or minus equation is an abbreviation for those two equations. All right. So now that we've dealt with the absolute value, well, now we just need to finish solving for x, right? And we know how to do that. Add 4 to both sides. On the left-hand side, we get 3x. On the right-hand side, we have to be a little careful. So it's tempting to write, well, 2 plus 4 is 6. So maybe it's 6. That's not right. Okay, so what I'm going to do is keep this as 4 plus or minus 2. Remember, this plus or minus is really an abbreviation for 4 plus 2, which is 6, or 4 minus 2, which is 2. So this right-hand side is either 6 or 2, right? And now let's finish solving. We'll do that, do all the arithmetic at the end. But I just want to, at every step, I just want us to remember that this plus or minus is an abbreviation for two different equations. Okay. So now to finish solving for x, we can divide both sides by 3. So on the left, we get just x. Right? So we're dividing both sides by 3. On the left, we get just x. On the right, we get 4 plus or minus 2 all over 3. All right. So again, we get two solutions to this equation. Let's write down what those two solutions are. Right? So remember, anytime you see a plus or minus, that's actually an abbreviation for two different possibilities. So let's calculate the two possibilities. So the first possibility is that x equals 4 plus 2 over 3. 4 plus 2 is 6, so 6 over 3, and that's 2. So the first possibility, their first solution is x equals 2. The second solution is x equals 4 minus 2 over 3. 4 minus 2 is 2, and 2 over 3 is, well, it's 2/3. So these are our two solutions. Right? The two solutions that we found to this equation are x equals 2 and x equals 2/3. So again, we got two different solutions. The thing to notice about this, though, is that these two solutions aren't just the aren't positives and negatives of each other, right? In earlier absolute value equations we looked at, the two solutions that we got were the same number but with opposite signs, and that's not the case here. And that happened because the inside of our absolute value wasn't just x, it was something more complicated than just x. All right. Incidentally, if you're nervous whether these are solutions or not, you can plug them in and check. Right? I won't do both of them, but let's plug in maybe 2/3. So if we plug 2/3 in for x, we get absolute value of 3 times 2/3 minus 4. We want to check, is that equal to 2? Okay, 3 times 2/3 is 2, so 2, absolute value of 2 minus 4, is that equal to 2? 2 minus 4 is negative 2, and the absolute value of negative 2 is 2. So it checked out. Right. So here we checked that 2/3 really is a solution. The other solution, x equals 2, also checks out, but I'll let you do that one. All right. So when we solve an absolute value equation with a positive number on the other side, we should expect to get two solutions, but it won't always be just the positive and negative version of the same number. It's possible to get two solutions that are genuinely different numbers like this. Okay, one more example. Let's solve this equation for m. So this one's a little complicated because there's stuff happening inside the absolute value and outside the absolute value, but that's okay. We know how to handle both of these situations. So first thing we should do is solve for, or isolate the absolute value. Okay, so right, keep your eye on this absolute value piece. We need to isolate that piece. So the first thing we should do is subtract 3 from both sides. We get 2 times the absolute value of 6 minus m equals, let's see, 7 minus 3 is 4. Now we should divide both sides by 2. We get the absolute value of 6 minus m equals 4 over 2 is 2. So absolute value of 6 minus m equals 2. And now we've isolated the absolute value, so now we'll deal with the absolute value. So remove the absolute value, 6 minus m equals, And remember, the price of removing the absolute value is to stick a plus or minus on the right-hand side. So plus or minus 6 minus m equals plus or minus 2. And now we can finish solving for m. So subtract 6 from both sides. We get minus m equals negative 6 plus or minus 2. Again, avoid the temptation of combining the 2 and the minus 6, because this isn't 2, it's plus 2 or minus 2, right? Okay. And next we need to multiply both sides by minus 1, because that will get rid of this minus sign that's on the left-hand side. And when we multiply the right-hand side by minus 1, remember, we're going to need to distribute this minus 1 like that. So on the left-hand side, minus 1 times minus m is m. And on the right-hand side, when we distribute this minus 1, we get minus 6 times minus 1. That's positive 6. And then plus or minus 2 times minus 1. Well, plus 2 times minus 1 is minus 2. And minus 2 times minus 1 is plus 2. So we get m equals 6 minus or plus 2. Well, that's still 6 plus or minus 2, right? It's just the subtraction and the addition are written in different orders. So let's write out these two solutions. As usual, we got two solutions, but let's actually write them both out. The first one is m equals 6 minus 2. And so that's m equals 4. And the other solution is m equals 6 plus 2. And that's m equals 8. So those are our two solutions, m equals 4 and m equals 8.